Hello friend, today I am discussing about the quantum problem which is very important for CSIR, NET, GATE, JAM and also for university, and this is also very important for Calcutta University. Okay, and it is the problem taken from 2018 of Calcutta University problem. Okay, so there is a question for the ground state psi 0 equal to alpha by pi whole to the power 1/4 e to the power minus alpha x square by 2 of a one dimensional harmonic oscillator. Find the average value of kinetic energy and the potential energy, so that kinetic energy equal to potential energy here. Given 0 to infinite e to the power alpha x square dx equal to half root over pi alpha, and 0 to infinite x square e to the power minus alpha x square dx, and equal to 1/4 root over pi alpha cube, and alpha, where alpha is 2 pi nu m by a squared. And this question may arise in CSIR or NET in this way. Option A, this is a function, then option A may be kinetic energy equal to potential energy equal to 1/4 h nu. Option B, kinetic energy equal to potential energy equal to half h nu. Kinetic energy equal to potential energy equal to h nu. And option D, kinetic energy equal to potential energy equal to n plus half h nu. Then which option is correct? How we can determine? Now what happened here? We can solve the kinetic energy by the kinetic energy operator. The kinetic energy operator here we can write kinetic energy operator T operator equal to minus h square by 8 pi square m d2 dx2. Clear? So this is the kinetic energy operator. Now what happened? The function is there, so expectation value of t or average value equal to 0 to, or here from minus infinite to plus infinite, the value may be changed from minus infinite to plus and infinite, minus infinite to plus infinite, psi g t operator psi g star d tau, or here since it is one direction, one dimension, then it will be dx. Okay, now we can put t average equal to minus infinite to plus infinite. We can put this function, that is alpha by pi whole to the power 1/4 e to the power minus alpha x square by 2 into the operator was this, that is actually minus h square by 8 pi square m d2 dx2 into psi star, that's mean this function, that is equal to alpha by pi whole to the power 1/4 into e to the power minus alpha x square by 2. Clear? And dx equal to this and this, it will be alpha y pi whole to the power half. Okay, and this term is minus h square by 8 pi square m, then integration minus infinite to plus infinite e to the power minus alpha x square by 2 into, there is a derivative, double derivative, then it will be minus alpha e to the power minus alpha x square by 2 plus alpha square x square e to the power minus alpha x square by 2 dx. Clear? This is double derivative just. Then what happened? Equal to h square by 8 pi square m into alpha to the power 3 by 2 divided by root pi minus infinite to plus infinite e to the power minus alpha x square by 2. No, there is no 2 because this one and this one equal to e to the power minus alpha x square by 2 into e to the power minus x square by 2 equal to e to the power minus alpha x square dx. This separate portion, this is separate portion, then plus this plus and this minus equal to minus h square by 8 pi square m to separate রেখে দিলাম, then alpha to the power 5 by 2 divided by root pi integration minus infinite to plus infinite e to the power x square e to the power minus alpha x square into dx. This portion is multiplication with this. Then what happened? Then you can write in this way equal to h square by, we can take 2, that's mean this is if we say that minus infinite to plus infinite, if we say it is 0 to infinite, then it will be 2 from the integration rule. Okay, then we can write it is 4 pi square m alpha by 2 divided by root pi integration 0 to infinite, because there is a 2 into 0, minus infinite to plus infinite means 2 into 0 to infinite, then e to the power minus alpha x square dx minus, it is also like this, h square by 8 pi square m, not this is 4, this will be 4, then it will be alpha to the power 5 by 2 by root pi, and this will be 0 to infinite x square e to the power minus alpha x square by alpha x square into dx. Okay, now what happened? Equal to, you can write equal to h square by 4 pi square m into alpha to the power 3 by 2 by root pi into half into pi by alpha to the power half minus h square by 4 pi square m into alpha to the power 5 by 2 by root pi into 1 by 4 into alpha to the power that's mean pi by alpha cube per half. Okay, equal to, we can write alpha pi 2 pi h by 2 pi equal to actually h by 2 pi equal to h cut, then there is a h cut square by 2m in minus this is also like this, alpha h cut square by 4m, there is a 4m, 4 into m, this is h cut, there is a just alpha, then equal to alpha h cut square by 4m. Now if we put the value of alpha, then what happen, 2 pi nu m by h cut into h cut square by 4m. Actually this value equal to 1 by 4 into 2 pi nu h cut, then h cut equal to h by 2 pi, then 1 by 4 into 2 pi nu into h by 2 pi equal to just 1 by 4 h nu. Okay, so this is the answer. Now if this is answer, then what happened, then the question, this first option is correct because this is the t equal to 1 by 4 pi. Now we again can calculate the value of V average. So V average equal to minus infinite to plus infinite psi g into V operator psi star g dx equal to, we can readily put minus infinite to plus infinite alpha by pi whole to the power 1 by 4 e to the power alpha x square minus alpha x square by 2 into what is the potential energy operator, just half k x square. Okay, value of V equal to half k x square, then alpha by pi whole to the power 2, sorry there is a 4 into e to the power minus alpha x square by 2 dx. Okay, now this will be alpha by pi whole to the power half, because this one and this one multiplication, it will be alpha by pi whole to the power half, then half into k, this is outside of integration, then minus infinite to plus infinite x square, there is x square into e to the power minus alpha x square dx. And we know the value of this because it is given. Okay, since it is given, so from this we can write alpha by pi whole to the power half into k into 1 by 4 into pi by alpha cube whole to the power half equal to alpha by pi whole to the power half into the value of k. What was the value of k? Value of k actually 4 pi square nu square m. This is well known value. Okay, this is the value of k for harmonic oscillator. Then it will be into 1 by 4 into alpha, that is pi by alpha cube whole to the power half. So it equal to 4 pi square nu square m into 1 by 4 a square divided by was that a square divided by 2 pi nu m, the value of, okay, so this is alpha, okay, so the value of alpha, that was this. Okay, alpha was 2 pi m by h cut. Okay, so this is actually value. Then equal to, can write 1 by 4 into 2 pi nu h cut. H cut again h by 2 pi, that's been 1 by 4 h nu, 2 pi cancel out. So we can say that T average must be equal to V average equal to 1 by 4 h nu. Okay, so that was the correct option. Now what happened? Then there was a question that determine the probability of finding a quantum harmonic oscillator beyond the classically forbidden region for n equal to 0 state. So what is the classically forbidden region? And the given was that the function of the wave function equal to psi 0 x, and the similar for the above, alpha by pi whole to the power 4 e to the power minus alpha x square by 2, where alpha is a constant, and there is another given value 1 to infinite e to the power minus z square dz equal to 0.1394. This is very important value. Okay, this is given. And if in CSIR or GATE or JAM or NET, this question is arise in this way, that there is a this and there is a option. Okay, the probability of finding a quantum harmonic oscillator beyond the classical forbidden region for n equal to 0 state is option A 1, or option B 0.1574, or option C 1.15, or option D 0.1253. So which option is correct? Now how we can express this? Actually, at first we need to draw a curve. Okay, what happened here? Can write or draw a curve in this way. What is this? Psi 0 x, and this is the xi or zeta equal to plus 1. What is this? Zeta equal to plus 1 and zeta equal to minus 1, or it may be called zeta 0. It is zeta 0. Okay. So this is a wave function. Okay. This is the probabilities where is maximum, but this portion and this portion is the classical portion. Okay. Beyond n equal to 0 region, forbidden region. Okay. Then at the turning point, that's mean at the turning point, the potential energy at turning point potential energy or total energy may be equal to just half k x0 square. This will be n plus half h nu. Okay. Now zeta is equal to root over alpha x, and if zeta 0 is the maximum classical value of xi, or zeta is the maximum classical value of xi, then xi 0 equal to root over alpha x0, then x0 square equal to ta 0 square by alpha, then half k x 0 square. What happened? This is actually alpha, half, this half k, and value of x square is this, then ta 0 square by alpha, and this must be equal to this, that is actually n plus half into h nu. And what happened about the zeta 0? The zeta 0 square equal to alpha n is alpha by 2 alpha by k into n plus half h nu, then zeta equal to or ta 0 equal to plus minus root over 2n plus 1, because what is the value of k? Because value of k equal to 4 pi square nu square m, and alpha equal to 2 pi nu m by a squared. Okay. Putting this value here, we will get only this, xi 0 equal to plus minus root over 2n plus 1. Then what happened? Then this equal to, now if the n is 0, if n equal to 0, then eta 0 equal to just plus minus 1. So from this graph, this is the plus 1, this portion is plus 1, this portion is minus 1. Okay, this portion is plus 1 and this portion is minus 1. Now what happened? So we can write the probability beyond the classical region equal to minus infinite থেকে minus 1 পর্যন্ত, from minus infinite to minus 1 and from plus infinite to plus 1 to plus infinite. Okay, what is this? Minus infinite to minus 1, that is this portion, minus infinite to minus 1 and plus infinite to plus 1 to plus infinite. Okay, so this is the value. Then psi 0 square, this is a position vector only. Okay, so this is x, so this is the probability psi square dx, and the limit from that is actually minus infinite to minus 1 and plus 1 to plus infinite, is beyond the classical region. So plus infinite to plus 1 to plus infinite equal to psi 0 square dx. We can sum of these 2 points, that's it. Minus infinite to minus 1 and plus 1 to plus infinite, this must be equal. The total probability, this probability and this probability, okay, it's equal. Then we can write 2 into plus 1 to plus infinite psi 0 square dx. This is the total probability. So equal to, can write 2 plus infinite to plus infinity, plus 1 to plus infinity equal to, there is a wave function that is alpha by pi whole to the power 1 by 4 e to the power minus alpha x square by 2. This is actually square, that is psi square dx. So equal to 2 into alpha by pi whole to the power half plus 1 to plus infinite e to the power minus alpha x square dx. And we know the integration value, how we can get? Now if we expand this in this way, zeta square or xi square equal to alpha x square, then dx equal to 1 by root alpha d zeta. Okay, derivative of this. So can write 2 alpha by pi whole to the power half plus 1 to plus infinite e to the power minus alpha x square dx equal to 2 into alpha by pi whole to the power half into 1 by root alpha integration plus 1 to plus infinite e to the power minus zeta square by into d zeta. Okay, this is equal to 2 by root pi into this is a given value, there is a given value. Okay, so there is a given value 0.1394 equal to 0.1394. So this value is equal to 0.1573. So this is the value. Then which option is correct? This option B is correct. Clear? So in this way we can solve the university problem or as well as CSIR and NET problem. Okay. There is another question in 2018 is also. Show that in the case of hydrogen atom, the probability of finding the 1s electron within the first Bohr orbit A0 is about 0.32, and this question may arise in CSIR, NET, GATE or JAM. In this way, the probability of finding the 1s electron within the first Bohr orbit A0 equal to 1 or 0.74 or 1.32 or 0.32, this way. Now we can easily solve this. We can easily solve this way, that the probability within 0 less than equal to r less than equal to A0, that is maximum value of r equal to A0, this equal to 4 by A0 cube integration 0 to A0 r square e to the power minus 2r by A0 dr. This is a well-known equation to get probability. This is equal to 4, 0 to 1, because there is a limit to 1 x square e to the power minus 2x into dx. Just to replace r in terms of x. Okay, then what happened? 4 into x square, there is a 2 terms, so we should do by parts. X square, then what will be the value of this? E to the power minus 2x by minus 2, or etar limit ache, the limit of this is equal to 0 to 1. So changing the limit in terms of x, okay, from r, minus 2 into minus half 0 to 1 x e to the power minus 2x dx. Clear? So this is by parts. So what will be the value? Value equal to 4 into, right, this way this is 1, this is half into e to the power minus 2. That's mean minus half into e to the power minus 2 plus x e to the power minus 2x by 2. There is also limit 0 to 1, then minus half, is half 0 to 1 e to the power minus 2x dx. Then what happened? Equal to 4 minus half e to the power minus 2 plus half minus half into e to the power minus 2 minus and minus half e to the power minus 2x by 2 is minus 2 for here, and this also contains a limit 0 to 1. Okay, third bracket close. Then equal to 4 into minus 1 into e to the power minus 2 minus 1 by 4. Then what happened here? 1 by 4. 1 by 4 is common. By 4 to e to the power minus 2 minus 1. Okay. Then equal to 4 into, what is the value? Value is minus 0.135, and what is this value? Plus 0.216, so it equal to 0.322, nearby equal to. Okay, so this option is correct. Okay, and this is the solution of this question. Now what happened here? There is another question. In this question, how can you construct the real wave function for 2px orbital using the following expression for psi 2 1 plus 1 and psi 2 1 minus 1. Okay, there is a given wave function is also there. Now how we can solve this? And there is another question. Draw the plot of radial distribution function against electron nuclear distance for 1s and 2s hydrogenic orbital. And this is easy. This is the graph, and this graph is you can get in every book. No, but what was that? This is university problem. Okay, now there is a given wave function is there, psi 2 1 plus minus 1 equal to 1 by root over 64 pi 1 by a0 whole to the power 5 by 2 into r e to the power minus r by 2 a0 sin theta into e to the power plus minus I phi, where the terms have their usual significance. Okay, now we can write in this way that the linear combination of this wave function is equal to 1 by root 2 into psi 2 1 plus 1 plus psi 2 1 minus 1. Okay, then what happened? then equal to 1 by root 2 this is big 1, so 1 by 64 pi into 1 by a0 whole to the power 5 by 2 into r e to the power minus r by 2 a0 sin theta into e to the power I5 plus e to the power minus I5. Clear? Okay. Then equal to, can write in this way that 1 by root 2 equal to 1 by root over 64 pi 1 by a0 whole to the power 5 by 2 into r e to the power minus r by 2a0 sin theta into, this is, what is this, the value of this equal to cos phi, it is 2 cos phi, that's 2 cos phi equal to this. Clear? So this is a function of radial function, okay, this is a radial function, this one. So we can write in this way that in spherical coordinate x equal to r sin theta cos phi, then what happened? Now this one may be right in this way, can write f function of r into r sin theta cos phi, okay, thus 2px equal to 1 by root 2 psi 2 1 plus 1 plus psi 2 1 minus 1. Clear? So in this way we can write, and this is the distribution, okay, distribution function, this is the distribution function for 2s and this is the distribution function of 1s. You should write this portion is only, okay. Now in 2017 there was a question, verify that the wave function a e to the power minus bx square by 2 is an eigenfunction of the simple harmonic oscillator in one-dimensional harmonic oscillator, or this is the one-dimension Hamiltonian. Now b equal to 2 pi root over mk by h, and terms have their usual significance. Find an expression for the eigenvalue. So what will be the eigenvalue? This or this? So in net gate or jam, this question may arise in this way. So what will be the answer? The answer is that the Hamiltonian for simple harmonic oscillator, Hamiltonian is for simple harmonic oscillator equal to minus h square by 8 pi square m d2 dx2 plus k, that's half k x square is potential energy, or potential operator, kinetic energy operator. Then how I can write it? This function is eigenfunction of simple harmonic oscillator in one-dimensional Hamiltonian. Then just we put in this way minus h square 8 pi square m d2 dx2 plus half k x square into psi equal to what happened? What is the value of psi? A e to the power this, okay, minus bx square by 2. Then you can write in this way minus h square by 8 pi square m d2 dx2 plus half kx square into just a into e to the power minus bx square by 2. Okay. Okay. Then what happened? We will do just derivation. Minus h square by 8 pi square m into a. What is the value? This is 4 b square x square minus 2b e to the power minus b x square plus there is another portion, it is half k x square into a e to the power minus b x square. Okay, or equal to minus half k x square into a to the power e to the power minus a into b to the power minus x square plus h by 4 pi into k by m whole to the power half into a e to the power minus b x square. Okay, plus there is another term, this is actually multiplication. Okay, what happened? Half kx square a e to the power minus b x square equal to half into h this is from here, so is 1 by, if we write in this way, 2 pi root over k by m a to the power minus b x square. So this is equal to h by 4 pi root over k m into a e to the power minus b x square. So what will be the eigenvalue? So this is the eigenvalue actually. So h psi equal to e psi. Comparing this, e equal to h by 4 pi root over k by m. So this is very important. Clear? Now what happened? For another question, there is a question from the eigenvalue of 10 above, make an estimate of the position of classical turning points x1 and x2, that is the values of x after which the motion reverses its direction, use proper arguments. Okay. Now there is nothing but at the turning point, in this way you should write, at the turning point since the kinetic energy equal to 0, then total energy equal to actually potential energy. Why it is only potential? In the turning point there is only potential, there is no kinetics. So at the point, that is turning point x1 and x2, the potential energy must be equal to half kx1 square equal to half kx2 square. So this actually we already get that this equal to h by 4 pi root over k by m. Thus we can write x1 equal to minus and x2 will be plus. That's when x1 equal to minus, that is position of the particle or quantum particle, that is minus h by 2 pi root over 1 by km whole to the power half, and it will be x2, that is plus equal to h by 2 pi root over 1 by km whole to the power half. Okay, so that was the answer. Again, there is another question, that what was or what will be the R average. This is very important. Always the R average for 1s wave function, it is equal to 0 to infinity equal to r into 4 pi r square psi square dr, and equal to, can write 4 by h0 cube 0 to infinite e to the power minus 2r by h0 dr. What is this? Actually, using gamma function we can also get 4 by h0 cube into, from the gamma function it is 3 factorial divided by 2 by a0 to the power 3 plus 1. So this is actually what happened? This is actually 3 by 2 a0. So this is solved. Now there is another question. What was that? The first wave function for the hydrogen is psi equal to 1 by pi a0 cube to the power half, into e to the power minus r a0, where a0 is the Bohr's atomic radius. Calculate the probability of finding the electron within a distance a0 from the nucleus. And there is a given value also. If this question is come in NET GATE or CSIR, then what will be the answer? Or what will be the option? There is 4 options. Now this is also we already calculate. Just we can get the probability equal to 0 to a0 1s into 1s. The volume element is d tau and it will be obviously r if we put the wave function. Then what happened? 0 to a0 into 4 pi r square into 1 by pi a0 whole to the power, this is to the power also half and whole to the power 2 into e to the power minus 2r by a0 into dr. Okay, this is equal to, can write in this way, 4 pi 1 by pi a0 cube 0 to a0 r square e to the power minus 2r by a0 into dr. Let r by a0 equal to x. Then what happened? R square equal to x square into a0 square and dr must be equal to a0 dx. Thus 4 pi 1 by a0 into pi cube 0 to a0 r square to the power minus 2r by a0 dr must be equal to 4 into 0 to 1. It is changed. Okay, this is changed. The limit change for x square into e to the power minus 2x dx. This is equal to 4 into, what will be the multiplication? There is a by parts. Then we can write x square to the power minus 2x by minus 2. This the limit was 0 to 1 minus 2 into minus half into 1, that is 1 x to the minus 2x dx. Okay, then this is actually 4 into minus half into e to the power minus 2 plus x e to the power minus 2 x by minus 2. There is also limit 0 to 1, then minus into minus half 0 to 1 e to the power minus 2x dx. Okay, and it will be 4 into minus half e to the power minus 2 plus minus half is minus half into e to the power minus 2, this value minus of minus half from here, e to the power minus 2x by minus 2 from this integration, and it also contains a limit. Okay, then what happened? Equal to, can write 4 into minus 1 into e to the power minus 2 minus 1 by 4 into e to the power minus 2 minus 1. So this is equal to 4 into minus 0.135 plus 0.216 equal to 0.322 nearby. Okay, clear? So this is the solution of this problem. Now what happened for 2s wave function for a hydrogen atom in psi 2s equal to n into 2 minus r by a0 e to the power minus r by 2a0, where n is a constant, r is the distance from the nucleus and a0 is the Bohr's radius. Find the distance from the nucleus in terms of a0 at which the radial probability density shows the maximum. Okay, so which option is correct? R equal to 3 by a0 or r equal to 4 a0, 5.23 a0 or comma 0.76 a0, or this, which one is correct? So to calculate this radial probability density, who is the maxima, we should get the probability. There is another same formula. Probability equal to psi 2s, actually there is a 2s square, small r square, is a radial distribution function. What is this? It is a radial distribution function. Okay, so since it is radial distribution function, then d probability dr will be 0 at maximum. Okay, then I will do just this. Now at first we will put here, what is this? What will be the value? That is actually n square. There is a 2 this into this, that's mean n square 2 minus r by a0 square e to the power minus r by a0 into r. Okay, so this is actually n square into e to the power minus r by a0 into, what will be the value? What will be the value? N square e to the power this, then 4 r square minus 4 r cube by a0 plus r to the power 4 by a0 square. Just I multiply this with this. There is a square term, so a minus b square. So we just put here from the a square minus 2ab plus b square formula. Now dp dr equal to what will be the value? This will be value high. That's this. I am doing derivation, that is first derivative with respect to r, equal to n square e to the power minus r a0 8 r minus 12 r square by a0 plus 4 r cube by a0 square plus n square e to the power minus r by a0 into minus 1 by a0. There is another value 4 r square in very high value 4 r cube by a0 plus r to the power 4 by a0 square. So equal to n square e to the power minus r by a0 8 r minus 12 r square by a0 plus 4 r cube by a0 square minus 4 r square by a0 plus 4 r cube by a0 square minus, there is another term, r to the power 4 by a0 cube. This multiplication just. Okay. This is equal to n square e to the power minus r by a0 into r by a0 cube 8 a0 cube minus 1 6 r a0 square plus 8 raised square a0 minus r cube. Okay, then what happened? This is very big problem. So at maximum this will be 0 or dp dr, this will be 0. Now this is equal to 0. Then there is 3 possibilities. First possibility is r equal to 0. It is not possible because at the particle will be in nucleus, no problem, so it is not possible. And second possibility is r equal to infinite. It is also not possible. Then what happened? Then r cube or 8r cube, actually this portion will be 0, this portion will be 0, or this portion will be 0, or this portion will be 0. Then what happened? If r equal to 0, it is not possible, r infinity is not possible, then what happened? R cube So this will be 0. So from here we can write in this way, if it is positive, that is r cube, this is r cube minus 8 r square a0 plus 16 r a0 square minus 8 a0 cube, this is ঘুরিয়ে লিখলাম, equal to 0. So it is possible. Then r equal to, what happened here? R equal to, there is again some possibilities, because if we take common, then what happened here? R minus 2a0 is common, then r square minus 6 r a0 plus 4 a0 square. So this is a cubical formula. There is a cubical formula, r cube minus 2 a0 cube. Okay. So what will be the value? Now this value can write here, that is r minus 2a0 equal to 0 or r equal to 2a0. This is a possible value, this is one possible value, and from r square minus 6 r a0 plus 4 a0 8 or 4 a0 square equal to 0, then r equal to 6 a0 plus minus root over Sitacharya formula 36 a0 square minus 4 into 4 a0 square divided by 2, whole divided by 2. Then r equal to 5.23 a0, and when it is minus, then r equal to 0.764 a0. So which option is correct? 2a0, 5.23 a0, 0.764 a0. This is the correct option. Okay. And there is another question, that justify the existence of non-zero energy in case of quantum harmonic oscillator in the light of Heisenberg uncertainty principle. From the Heisenberg uncertainty principle, what happened? For harmonic oscillator, coexist of kinetic energy and potential energy togetherly, that's mean E equal to px square by 2m plus half kx square. Actually that is actually H nu into v plus half. Okay. Where v is the vibrational quantum number. The uncertainty principle tell us that delta x into delta px equal to h cut by 2. Now delta x square equal to x square average minus x average square. And what was that about px square? This is also can say that Px square average minus Px average square. For the simple harmonic oscillator, x average equal to 0. Then delta P x equal to root over Px square average, and delta x equal to root over x square average. At the ground level, if V is 0, if E0 equal to 0, then Vn was that. If V or V EV is actually, that is EV, V is 0, then what happened? Then can write in this way, delta Px into delta x. What will be this? Since x square average not equal to 0, then can write delta x into delta Px not equal to 0, which is consistent of the Heisenberg uncertainty principle, which tells us delta x into delta Px equal to h by 4 pi. The 0 point energy is non-zero in case of harmonic oscillator also. Thank you.